This is Carl from LunchboxSessions.com. Four-port directional valves are very common for moving a hydraulic cylinder into position, but if that four-port valve is the type that has three positions, a center position, as well as two directional positions, how is that center position chosen from among the options that are typically available? Here are four of the most common valve centers available to four-port three-position valves. We could have a tandem center valve, which will connect pump back to tank while isolating A and B. We could have a float center valve. I think you can see what's happening there, where only the P port is blocked. We could have a closed center valve where all four ports are isolated, or we could have an open center valve. So in this particular circuit, we're in a welding shop and large cylinders have been embedded in the concrete floor and are being used to position I-beams and get them lined up just right before the weld is applied, where one beam joins another. The circuit as shown is showing valves with open center. That is, the pump and the tank port and the A and B work port are all connected together. So if I go to move the valve for the left cylinder into the extension position, does the left cylinder move upward? No, it does not. There is a large leakage path through the valve center at the circuit on the right. Let's work with the valve on the right for the cylinder on the right, and notice that the right-hand cylinder will also not raise because there is a leakage path for the pump's flow back to tank through the left-hand valve. So no way to trap any pressure, and the cylinders do not rise. In addition to needing to be able to position each cylinder individually to the correct position as we would like, an additional criteria is that we would like to avoid pumping fluid over the relief valve for prolonged periods of time while the cylinders are in their hold position. And we're going to be leaving the pump running, so what can we do with our valve center choices to try and achieve the goal of getting into position as we want to, one valve at a time, without pumping oil over a spring-loaded relief valve, which would just heat the oil and consume excessive amount of electricity for the electric motor turning the pump. So a pair of open center valves do not work. We've already established that. Let's try something else. Perhaps we're thinking that the tandem center valves would be a good choice. So now our valve centers have connected our P to T port, and we're still nicely unloaded. The pump's flow is unloaded to tank whenever we release the valve handles into the center position, but will the cylinder on the left rise when the valve is moved to the P to A position, the extend position? No, it will not. Just like as we were working with the open center valves, while trying to extend the cylinder on the left, all of the pump's flow has a leakage path back to tank through the valve on the right. Same holds true for the other direction. Perhaps if we were to introduce a valve on the right that blocks the P port, in this particular case I've chosen the float center, what will happen now? When I move the valve on the left into the extend position, will the left cylinder rise? Aha! Yes, it does. The left cylinder rises because when we go into the extend position, we find out that the pump's flow is blocked over here at the right-hand valve, and so the only path for the pump's flow at that moment is into the cylinder to extend it. So that seems to be working nicely. And our pump is unloaded back to tank whenever the valves are in their neutral position, center position. But what about the valve on the right and the cylinder on the right? Are we able to raise that cylinder? No, we cannot, because once again, we have that leakage path through the valve on the left-hand side. So it's starting to look as though the only way we will get control over each cylinder individually and be able to position the cylinders exactly as we like, hold them in position one at a time, is to simply use the closed center valve on each side. It gives us lots of options for how to keep our cylinder in position. A and B work ports are blocked on each side, so holding our cylinders in position is working out quite well. The only difficulty we're having now is that all of our pumped fluid is passing over the relief valve when the system is in neutral, and that's causing us to build heat in the fluid and consume excessive electricity. What else can be done? Well, it's not untypical in a factory environment to find that many valves are of the closed center variety where the P port is blocked, but to find out that instead of using a fixed displacement pump, instead a variable displacement pressure compensated pump is in use. And now we find out that we do not pump flow over the relief valve. We find out that when there is no flow in the system due to blocked valves or cylinders that are deadheaded, the pump simply resizes itself to a near zero displacement pump and waits for a flow path to develop once again, and then the pump returns to full displacement. So that's the advantage of putting a pressure compensated pump to work, and without pumping any fluid over the relief valve, the pump does allow for a fair amount of energy to be saved. Pressure is being maintained, but at a very, very minimal flow rate. Only the flow rate needed to make up for internal leakage inside the pressure compensated pump or any other internal leakages that may exist in the hydraulic circuit. So that is a good way to save energy and avoid building heat. Well, let's say now for argument's sake that we will not be provided with a pressure compensated pump. We've been forced to work with a simple fixed displacement pump, and we still wish to avoid pumping fluid over the relief valve. What else could be done? Well, let's go back to the tandem center valves that we explored earlier. Remember that we were unable to lift the cylinders one at a time due to the leakage path that is present on the opposite cylinder circuit anytime we go to raise one or the other cylinder, but perhaps there's something we can do to change the plumbing arrangement. Notice that right now our valves are plumbed in parallel. That is, leaving the pump, we have two parallel paths back to tank. We have a pump parallel path through the valve on the left, back to tank, and we have a pump parallel path through the valve on the right, back to tank. But what happens if we change to a series configuration for the directional valves? So keep an eye on this spot right here on the schematic while I change the plumbing to series connection. Here we go. Do you see what has changed? We no longer have two parallel paths for our directional valves. Our pump is feeding the first valve, P to T, through a tandem center valve, and the return to tank port from the valve on the left is passed to the pump inlet port to the valve on the right, and then back to tank. So they are now plumbed in series. We are still unloading the pump back to tank when the valves are at neutral. So our pressure is minimal, pretty much zero. Our relief valve is closed. We're not building any heat, but Can we raise one of the cylinders? Absolutely. Every time we go to move one or the other directional valve, we find out that there is only one flow path for fluid against the bottom piston in the cylinder. And so we are able to trap pressure and raise each cylinder as needed. So that's a working scenario. Valves connected in series allow us to work with a simple fixed displacement pump without pumping fluid over the relief valve. I hope that's been a useful lesson on valve centers. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.